Thank you and welcome everybody to today's Ecological Continuity Trust webinar. Just a couple of reminders. Please keep your microphone muted during the webinar, and if you can turn video off, that generally helps with the bandwidth. If you have, we're going to try and save questions towards the end, but please feel free to pop questions in the chat as we go through, and then Ben will moderate the questions at the end. Now, I'm very pleased to introduce Bruce Lascelles, who's Director of Sustainable Land Management at Cardiff, where he's senior leader within the environmental business. Bruce is currently a consultant, but he has an academic background in soils, focusing on soil development and erosion. A key area of expertise since he's been a consultant has been around hydrological assessments and development of strategies for creation, restoration and translocation of valuable habitats. Today he's talking to us in his role as President of the British Society of Soil Science, and he's going to talk to us about the need for engaging more scientists in long-term ecological experiments. Over to you, Bruce.
Brilliant, thanks. Thanks very much, Carly. Okay, I'll just share my screen, and hopefully you can all see that now. Brilliant. Okay. Well, yeah. So thanks, Carly, and thanks very much for the invitation to speak at this session. And I suppose I should start off by saying that this has come about as a result of a developing partnership between the British Society of Soil Science and the Ecological Continuity Trust, which I think is a really, really positive development. And the initial discussion leading up to this was around the crossover between soils and the above ground habitats and communities they support. And importantly, the need to understand how manipulations of either have an effect on the other. And I've spent quite a lot of my career trying to bridge this divide, and I'll share a few examples. But I think, fundamentally, I absolutely agree that we need to promote long-term land management experiments and do more of them, and really just having more information and more data about both above ground and below ground aspects of that. So as Kai said, I'm here in my role as the current president of the British Society of Soil Science, or BS3, as we're known by many. And I've got a couple of questions I just want to ask using Slido. So if you look at what you can see on the screen now, if you can just open a browser window and just type in slido.com, and that should bring you up a small dialog box where you can put in the code, ignore the hashtag, just 92930. And we're just interested to know how many of you are aware of a BS3, or even if just to some extent. So I'll give it a few minutes for those results to load through. Okay, and hopefully you can see the results changing on the screen as people put their votes in. Okay, brilliant. Well, it's good to see that there is still 0% on the word no, and I think that's really encouraging. And I suppose that perhaps also reflects perhaps some of my experience, particularly as in my role as president of BS3, that there is a lot of interaction between organisations, between professional bodies, etc. And absolutely, I'm not coming to this from a perspective that there's no interaction. I think there's a lot of good interaction. Brilliant. Okay. Well, thank you for putting those votes in. So just to come back then to the British Society of Soil Science, most of you are aware, but I thought it worth, I won't linger too much on these, but just giving a bit more perhaps detailed information about who we are, what we do, and in particular, I've got a bit of information about the journals we publish, because clearly there's a lot of synergies here in terms of the research outputs as well. So the British Society of Soil Science is an established international membership organisation committed to the study of soil in its widest aspect and to the advancement of soil science. And the Society brings together those working within academia, practitioners implementing soil science in industry, and also all those working with or with an interest in soils. And I must admit, I forgot to put our new logo on here as well, because this 2022 is our 75th birthday as a society as well. So quite an important year for us as well. And at the kind of the heart of the society, and it's long been this way, are our journals. So we publish two journals: the European Journal of Soil Science and Soil Use and Management. And we also publish a magazine called Soil Matters, which was previously called the Auger, which some of you may have come across as well. So soil use and management, the focus of this journal is sort of publication of papers in soil science, in earth and environmental science, agricultural science, and engineering fields as well. And the papers included in soil use and management consider the underlying mechanisms governing the natural and anthropogenic processes which affect soil systems. And we hope that this information should inform policymakers, and practitioners on the sustainable use and management of soil resources. And this journal also focuses on sort of interdisciplinary studies, so linking soils with climate change, soils with biodiversity, soils and the UN's Sustainable Development Goals as well. So very much a sort of an application type focus in that journal. And then the European Journal of Soil Science is an international journal that publishes outstanding papers in soil science that advance the theoretical and mechanistic understanding of physical, chemical, and biological processes, as well as their interactions in soils, from molecular to sort of continental scales in both natural and managed environments as well. So two really important journals, and I'm sure that there are publications in here, or no publications here, that do relate to research that's happened or been undertaken on some of these long-term monitoring sites as well. As a society, then, we've also trying to increase our sort of outreach and sort of information around soils to a wider audience as well. And as part of this, we produce a range of guidance and science notes, which you can see some of them on the right-hand side of the screen there as well. And most recently, we produced a science note on soil carbon, and again, really timely to get that out there from a very much sort of an evidence-based, a scientific base as well. And we also have a suite of notes detailing the competencies which should be expected of a soil scientist, and they come under this title down in the sort of bottom right-hand corner: working with soil competencies. And this is a series of 10 documents, starting with there's an introduction as well, but starting with the sort of the required foundation skills in field investigation, soil description, and the interpretation of that information. But again, perhaps pertinent to this discussion is they also cover topics such as soil handling and restoration, conservation of natural habitats, and research and development leadership as well. And the sort of the driver for this was really, I'll come back to this again in relation to soil science, was kind of just the lack of guidance, the lack of maybe status of soil science as a scientific discipline as well. And having produced those competencies, it was very clear, and we're very aware that there needed to be support to those who wanted to develop their skills in soil science. And so along with the competencies and to support those competencies, the BSQ also run training courses. And I've just put up there on the screen that we're going to be delivering a full training program in advance of the World Congress of Soil Science, which I'll mention again later as well, as part of the soil judging competition. And that's the soil judging competition is a competition where teams from around the world come together at a location in Scotland, and they'll have a couple of days of training in those fundamentals: digging a pit, describing a soil, describing its characteristics, identifying the soil type, and then on the final day, it sort of goes into competition mode, I suppose, and they're given a fresh soil pit to describe and to see how well they do in that process. So that's just sort of a brief introduction to the society. I suppose then sort of moving on to formulate around the discussion today. Soils don't exist on their own and in isolation of other factors. They're influenced by geology, topography, climate, and importantly for this discussion, time and land use and land management. And I've included a few images here from some of my recent projects, which just show kind of the variability in those, or sorry, how the variability in those soil forming factors can drive very different soil characteristics at quite small spatial scales. So this top set of three images, these are from a transect of probably only around 100 meters in length across bands of limestone and siltstone, with the soils changing from topsoil over solid bedrock, which you can see on the left-hand side, to slightly deeper soils with some subsoil over the fractured geology. You can see I just put some red markers in there to delimit the base of the topsoil. And then finally into sort of, very, very deep profiles over highly weathered rock. And these bottom three images are soil cores from an infield meander on the River Severn, a triple SI, where the characteristics at any given location have been determined by that kind of unique sequence of sediment input and periods of stability and peat accumulation over time as well. And I suppose this kind of moves us onto that main theme, the absolute importance of understanding our landscapes as systems, as our landscapes as diverse and not simple, and therefore the need for multidisciplinary research. In order to understand those and understand any one part of it, you need to have that understanding of the other parts as well. And I thought I'd just draw your attention to the revised World Charter, the revised World Soil Charter, which some of you may be aware of. And this picks out this kind of aspect specifically at two levels, and I've just highlighted that paragraph 6. There's the requirement for multi-level interdisciplinary initiatives in order to properly understand these systems, but also then importantly the requirement for local knowledge as well, and I think that is absolutely important in understanding these, and particularly at a global scale as well. And this is really coming out in lots of other conversations that I'm having, for example, with the Chartered Institute of Ecology and Environmental Managers, the Landscape Institute, Syria, as well as an organisation, and for those who don't know, Syria is the Construction Industry Research and Information Association, and again they've now got a focus on soils because it's one of the aspects they feel has been missed in construction projects historically. And so I think we are really moving into an era where the importance of soils in understanding that system, and particularly so for this conversation, the biological system is moving to a new level. And I guess then just before, so I'll move on to maybe some of the more more of the specifics. I'm interested to know what your background or what your area of focus is. So hopefully, if you go to practiceslido.com again as well, and you've got that open, you should now see this next question, and this is free text. So if you can just type in a word or two around, what's your area of background, area of focus, it'd be really interesting to gauge what that spread is. And and that's going to come up on the screen now as you log your responses. Okay, so we've got biology, ecology, microbiology, plant communities, soil, archaeology, soil physics, monitoring, soil carbon. Okay, so quite a range, but it's good to see soil in there as well, but obviously quite a focus on biology, biodiversity, management, and so on as well. Brilliant. Okay, thank you very much. So just perhaps just before I just pick on a few specific examples, I just wanted to share this concept, which I really like, and it's not mine. It's a slide I've taken from a presentation by Professor Ratan Lal, who leads the Carbon Management and Sequestration Center at Ohio State University. And he set out this concept of the soil life nexus. There can be no life without soil and no soil without life. And I think this really really well highlights the interconnectedness and perhaps the broader need to be joined up and avoid that working in silos. And I think we've come a long way, and that's perhaps the extreme at the moment. But there is good connection. We just need to make sure we're building on that and doing much more. And so this I like to diagram this. Soil health can be our starting point, and that soil health comes from that good sustainable land management. And so therefore we need to understand what that link is, how we affect the above ground plant communities and vegetation, and what impact that has on our soils. But then soil health supports plant health, supports animal health, human health, environmental health, and therefore planetary health as well. And as Professor Lal has stated, the health of all of these is one and indivisible. And I think that's a really strong message that can support the greater collaboration across disciplines as well. So I've spent a good part of my career working with ecologists to highlight the importance of the below ground ecosystems of the soil when trying to understand the above ground ecosystems, how they function and how they can be enhanced. And I know Penny's on the call, but early on in my career working for Penny, I worked on the best practice guide for habitat translocation, which was published by Syria. And again, I do like the quote on the front. I think it's still very relevant. A good copy of the Mona Lisa is still not the Mona Lisa. And I think this is really that recognition that when you manipulate a natural system, it will change for good or bad, but it will change. And there's lots of focus in the guidance on sort of planning ecological value, contractual requirements, mechanisms and aftercare, etc. I think it was really important at the time that there was this recognition of the importance of soils and understanding that soil system. And that soil system includes the hydrology, the soil moisture aspect, topography, etc. as well. But it was a really good point. And again, unfortunately, one of the drivers for producing the guidance was that there were good examples of where, good is probably the wrong word, but examples of where habitat notification had failed to deliver what was set out to do because that physical environment had not been right, or it changed to such an extent. So changes in soil moisture, in waterlogging, that just the basics of the comparability of materials between donor and receptor site as well. But I think importantly in that guidance was this inclusion of a requirement to monitor the site and report on the findings. But unfortunately, and this was published in, I think, 2003, I think it was, so nearly 20 years later, my experience is that very often that monitoring is omitted, and even more rarely is that monitoring does that monitoring cover the soils themselves as well. And as a consultant, the majority of projects I've worked on have also just not included that long-term monitoring of soils. It's not asked for by consultees or by stakeholders, and and probably therefore as a result, very rarely is there any budget allocated or available to do that. Now, there have been times when working on a project, soil monitoring itself has been excluded on the basis that the above ground biodiversity will be monitored, and therefore the supposition being that the successful establishment or creation of that habitat should be enough to show that there are no other problems. But I think, as I kind of alluded to at the start, I think this perhaps just reflects the status that soils have had over the years. Soil science is very often referred to as the Cinderella science. Over the years, we've had really strong legislation covering biodiversity, covering water and air quality, but nothing on soils. When we were in the European Union, there was a proposal for a soil framework directive, but that was dropped in, I think, 2014. And unfortunately, disappointingly maybe, the UK were one very strong opposer to the implementation of a soil framework directive. I realise we've left Europe now, but things are changing, and you may be aware that late last year, European Commission produced or published the EU soil strategy, taking us up to 2030. And hopefully at some point this spring, we will have this soil health action plan will be published and launched as well. And I really do hope that these things and what we're seeing, the sort of level of change and the prominence perhaps of soils, I haven't included it here, but I've got a slide from another presentation just picking out some of the sort of the press from last year where soils were on the BBC, in mainstream media and so on. And I hope that this does drive then an increased need for there to be that focus on soil monitoring, on long-term soil monitoring, but in collaboration and in partnership with the monitoring of other aspects of the environment as well. And because these sites where we get the long-term view of the changes resulting from land management are really important, and they are going to become only more important particularly as we get this focus on soil as a carbon store. But also I do really hope that the carbon isn't the only driver for more monitoring and more sustainable land management, and that we do truly take account of the full range of soil ecosystem services which can be provided if we get it right as well. But I think, coming to some specific examples, I think this the issue of long-term soil data is perhaps exemplified by this project one I worked on recently. It's a site in the southeast where ancient woodland was being affected by the scheme. My involvement, or Arcadis involvement, came at the construction stage in an assurance role for the client, and it became very, very clear very early on that there was little data available on the soils to help inform the development of a site-specific approach to soil handling and reuse. And therefore, there was very little information available for us to use to engage with stakeholders, to explain what we were doing, the rationale for why a certain methodology had been chosen, why we considered it to be a success. And that was not just with the stakeholders, but also with the contractor, because to do anything other than run a bulldozer through things takes longer, takes more time, costs more as well. And so trying to find that justification and having the evidence to back that up was really highlighted, or the lack of evidence was really highlighted in this situation as well. And in order to try to bridge that gap, we were able to secure access to a site where ancient woodland soil and stool material had been salvaged and reused around, now it would be about 15 years ago. And gain access also to the original woodland, in situ woodland, to adjacent arable areas, and to the translocated soils, and an area which just comprised subsoil as well, where during construction they'd effectively somehow run out of translocated soil material, and therefore there was just subsoil left as well. And I was able to secure a small amount of funding through Arcadis to support a research project in collaboration with Cranfield University. And again, I haven't included it all here, but the findings were really interesting and highlighted, I think, what we expected to see, that there were these differences in the soil characteristics between in undisturbed ancient woodland through to arable soil, but also that translocated soil in the middle. And particularly, we were focused on the microbiological community in there as well. And even after 10, 12 years, those differences were still visible. And this was an interesting project because it had 10 years of ecological monitoring associated with it, which was reasonably rare, perhaps from my experience on these major projects. And that ecological monitoring had concluded that the project had been broadly successful, with good representation of ancient woodland indicator species present at the end of the monitoring period. But clearly there was still more time needed for the soils to fully recover and that then raises this question about whether the soils would ever fully recover to their undisturbed state, particularly from a microbial perspective. We managed to get, I managed to get a bit more funding to do a second project with Cranfield University to look at another site with a different time frame, and it did suggest that there was a trajectory towards restoration and fuller recovery. But again, I think the question still remains slightly unanswered, and this is a big question because we need that long-term monitoring data, or speaking for myself as a soil scientist, I need that long-term monitoring data to properly answer some of these questions and strong challenges from stakeholders as well. And I've got lots of other examples from projects where we've had to kind of argue the case for more soil information to go alongside the ecological monitoring, to help inform design, to help understand what success actually looks like as well. But this is by no way long-term monitoring that we were able to achieve on these projects. And the two examples I just sort of picked out, and I won't go into the detail on them, but on the left-hand side is sort of wet grass and recreation on the Somerset levels with the typical pattern of shallow sort of linear scrapes across the fields. And then on the right-hand side was a sort of pipeline project, a pipeline installation project in South Wales, and really the key here was just understanding the what changes would happen in reinstated soils which have been stripped and stockpiled, which you can see in the image here. You've got topsoil and subsoil separated, but also then there's this technique of macro turfing, so trying to limit the disturbance to the soils as well. And we got some really interesting data from that, but again, it was time limited. It was a struggle perhaps to get to that point anyway. And I think this is going to become more and more important, this ability for us to have access to good quality long-term monitoring that has the soil information there, but the soil information linked to what's happening above ground as well. And I've just as a trying to sort of exemplify this, I've pulled out this IEMA publication. This was launched just I think 2 or 3 weeks ago as well, so very, very fresh. And I hope this will be a really important driver, because in particular this pulls out this sort of highlighted comment there as well, requiring impact assessments to take account of soil functions, ecosystem services and natural capital as provided by the land and the soils as well. And this will be very sort of a very novel requirement, particularly for a lot of soil scientists and those working in environmental impact assessment. And we're going to need information to support the justification for additional monitoring, additional mitigation to go into projects, because as I said before, that's going to cost money, and people are going to look at that. What are we getting for money? Why are we having to do this? What's the justification? Can you? The sort of question that I get asked is, can I confirm? Can I prove that it will be successful? And I think then I just wanted to raise this as well, to highlight this as well. Again, a very, very recent publication, and it's a very timely publication from Peter Gregory. It's just been published in the European Journal of Soil Science, and it's kind of discussing perhaps what we're here today to sort of think about, that connection, and it's kind of focusing on discussing the definition of soil and how the role of plant roots has been perceived and understood in relation to how soil functions, and therefore possibly actually how that perception has affected how research projects have been set up as well. And I've just pulled out the final conclusion from the paper, and the wording I think is very important, I think, here as well. So Peter concludes with, the formation and functioning of soil are dependent on the presence of roots and their associated organisms. For some purposes, roots can be regarded as merely in soil, but for many purposes they are a vital component of the soil system and of its functioning, and should specifically be recognised in the definition of soil. As we understand more about the signalling and communication between roots and organisms, and the chemical, physical and biological changes occurring as a result of that root-soil interaction, we shall gain an increased understanding of the processes influencing the genesis of soil profiles, and then importantly, this last bit, the interaction of pedogenesis and plant diversity, and how the plant soil system might be better managed. And I think that really, again, if we're looking for levers, for hooks, for justification as to why we need to push for greater sort of long-term monitoring that takes account of both above and below ground, these are really, really tangible things that we can sort of put on the table as well. And in preparing for this presentation, I did reach out to a number of people to seek their views, and most did respond to say that ecologists and soil scientists can and do work really well together. And it was encouraging to hear that, and that would be my experience too as well over my career. But most people also did comment that there was huge scope for more collaboration. And interestingly, an interesting point was raised by Emma Sayer from Lancaster University, and that was around that most soil studies are destructive, and I hadn't perhaps quite thought of it in that way. So destructive and require repeated sampling over time, and she sort of noted that this was a major problem on small plots like the 3 by 3 meter plots at Buxton, where she's been doing some work. And so Emma said she's had to seek methods that use very small amounts of soil that really limit that damage to the system in that very small plot, but did feel that this was a limitation. I'd be really interested to hear other people's views on this in the discussion afterwards as well. But generally, people I spoke to did just make that kind of broad comment that we need to understand the systems, because we need to make sure that when we're thinking about land management changes, ecological enhancements, we need to match the habitat to the soil conditions. And that may seem very obvious to us on the call, but definitely from my experience, that does not always happen. And I've got plenty of examples where I'm kind of handed a landscape plan or an ecological mitigation plan and told the soils aren't right for this. I sometimes try and take people back to the basics and say, okay, well, let's look at what soils we've got, and let's look at what those soils can support. And so maybe just to close, just this final question, perhaps, which comes to the nub of it. Do you see opportunities for greater collaboration between soil scientists and ecologists? Great to see it. Yes, it's already collaborating in there really, really quickly. And just while you're responding, that the research which comes from these long-term monitoring sites is really important. And I've had a quick look through the list of publications on your website, and clearly there are really good interactions already. But I know as a soil scientist that soils have not had the prominence they deserve. And there's evidence from long-term monitoring programs, which includes the soil system as well, is absolutely essential, as I've said, to answer many of the questions which I get asked. And in particular, perhaps as we move forward and we're starting to seek more opportunities that that soils and land can play in that drive to net zero and a sustainable and a nature-based future. And perhaps the final point in thinking about this, I think also, I've given an example of sort of development construction projects that I've worked on, and managed to get a little bit of research work out of those. But I think there's huge scope for more research and more monitoring to look at what has actually happened on some of these projects. We've got a huge range of different landscapes and different soils and different habitats. All of which, it's a potentially really important data for future decision making as well. Brilliant. Again, I'm really pleased to see there's 0% on no. I did keep the questions really very sort of simple, but that's good to see. And yeah, so just to finish up, I am really, really excited about the developing relationship between BS³ and ECT, and I do hope that we can continue to foster valuable discussions which enable us as a community, a joined up community, to take the science around land use change and ecological enhancement and long-term sustainability forward as well. And as some of you will be aware, BS³ are hosting the World Congress of Soil Science in Glasgow this summer, and I'd love to see some of you there as well. It is a scientific congress, but as part of it, we've also got a day that we've been developing, focusing on policy, to bring together insights from around the world on where policy and legislation has supported changes. And again, I think that's a really important aspect that we need to seek in the future, is to bring soils up onto a level par with I suppose there's other elements of the essential life support system that we need as well. Yeah, and I will stop there, and thank you very much for your attention, and I look forward to the questions and debate.